Hello and welcome. Today, we're going to dive into a really foundational paper by the father of our field, J.W. Forrester. Now, we often think of his work in corporate and economic modeling, but his 1992 proposal for K-12 education, well, it offers a profound way to apply our core principles. He basically argued for using system dynamics to completely transform learning itself. And you know what? His ideas feel more relevant now than ever. So let's explore his vision together. Forrester kicks things off with a pretty sharp critique. He says that our traditional education system is great at stuffing students' heads with information, but it completely fails to give them a mental framework, a way to connect all those facts to the messy, complex, dynamic world we actually live in. And this leads to what Forrester calls a crisis of complexity. So let's unpack that diagnosis. Let's really dig into where he believed the conventional model was failing to prepare students for the world as it truly is. Forrester argues the failure really comes down to a structural mismatch. Education is taught in these neat little silos, right? Science is here, history is over there, and it completely ignores the interconnectedness that we know defines all complex systems. Even worse, it presents these static snapshots of the world, totally missing the crucial dimension of time and how things change. We're basically handing students a box of puzzle pieces and just expecting them to assemble a coherent picture of the world. And without the right mental models, that's a nearly impossible task. Our intuition gets built from really simple experiences. You touch a hot stove, you feel the pain immediately, right here, right now. This hammers home a powerful mental model that cause and effect are always close together. But here is the absolute key. In the big, complex social, economic, and environmental systems that actually run our world, that intuition is dangerously wrong. The real cause of a problem is often far, far away from where the symptom shows up, both in time and in space. And our education system does almost nothing to prepare us for that reality. So, this brings us to Forrester's solution, which really has two main cornerstones. The first one is what he calls the dynamic framework, a way to finally give a unifying structure to all knowledge. And of course, the framework he proposes is system dynamics. Its real power here is its focus on feedback structures as the things that govern behavior. By teaching students how to see these underlying feedback loops, we give them a tool to connect the dots between action, result, and future action, and it works no matter what the subject is. This quote from Jerome Bruner just nails why a framework is so critical. Our brains, it turns out, are wired to forget random details. To actually retain knowledge, we have to place it into some kind of structured pattern. System dynamics is that pattern. And this is the secret to creating unity out of all that fragmentation. By focusing on what we call generic structures, system dynamics shows how the exact same feedback and stock and flow setups appear everywhere. The structure that makes a pendulum swing is fundamentally similar to the one that drives business cycles. This creates knowledge that you can actually transfer, allowing insights from one field to suddenly apply to another. Okay, but having a powerful framework isn't enough on its own. You need a new way to teach it. So let's move on to the second cornerstone, flipping the traditional classroom from a place of passive reception to one of active exploration. This new pedagogy requires a total reversal of how we normally teach. The conventional way, on the left, starts with facts and just hopes that students eventually get to the big picture, the synthesis. But Forrester argues this almost never happens. The new approach, on the right, starts with synthesis. You give them the big picture first, the dynamic model of the whole system. And that framework creates a need to know, which drives them to explore the facts, because the facts finally have a purpose. We call this pedagogy learner-centered learning. So instead of just passively listening to lectures, students become active researchers. They work in teams, they explore complex problems, and they build their understanding together. The classroom becomes more like a research lab. And in this model, the teacher's role completely changes. They're no longer the sage on the stage just dispensing facts. They become the guide on the side, a facilitator, a resource, and really a co-learner who helps students navigate their own discoveries. So the big question is, does any of this actually work in the real world? Well, let's look at the incredible results from the experiments they conducted in Tucson, Arizona, where they put all these ideas to the test. This quote comes from Frank Draper, an 8th grade biology teacher. And after he implemented this new model, he discovered something pretty amazing. It wasn't just more effective, it was also way, way more efficient. The results were just stunning. Draper covered his entire year's curriculum with a third of the school year left over. Engagement went through the roof, discipline problems basically disappeared, and get this, students were so motivated, they started showing up to class early and staying late, all on their own. This little anecdote right here shows the holy grail of education: knowledge transfer. After modeling a simple system of exponential growth in a petri dish, a student immediately recognized the generic structure and applied it to a massive global problem. I mean, that's the whole point. That's the power of this approach. And this wasn't just happening in science class. A literature teacher, Pamela Hopkins, saw the exact same transformation. Her classroom, which was full of students that many had written off as slow learners, just came alive with kids talking directly to each other. What did she do? She used a Stella model to map the psychological feedback loops driving Hamlet's behavior. And suddenly, her students could grab onto these complex, abstract themes. The model gave them a concrete tool to analyze and discuss what was previously just thin air, empowering them to take charge of their own learning. So, what does this all mean for the future? Well, these experiments point toward a totally new vision for education and a new kind of learner. Maybe one of the most profound findings was this: those old labels of fast or slow learner were completely irrelevant here. This approach unlocks potential in everyone, which should really challenge our basic assumptions about academic ability. The ultimate goal, as Forrester saw it, is to reverse this centuries-long trend of chopping up knowledge into tiny little pieces. It's about creating holistic thinkers who can see the connections, who understand that common core of concepts that applies everywhere. Kind of like a modern-day Renaissance ideal. And that leaves us with Forrester's final, challenging question. If we have the principles and we have the tools to build a framework for real understanding from the very start of a child's education, then what are we waiting for?